What you see now is quality assurance of Carl Zeiss in early days. Carl Zeiss used a hammer to smash optics where he was not satisfied with. You can imagine that this is not really suitable for modern times. And I want to show you in a short video what we are doing nowadays in a Zeiss imaging lab. So this is our imaging lab. For the qualification of a smartphone camera system, we are testing more than 150 camera modules. By doing this, we are capturing thousands of images that have to be analyzed. So the typical development process of a smartphone camera system consists of three phases: the engineering, validation and testing phase, EVT, the design validation and testing phase, DVT, and the production validation and testing phase, PVT. During all these three phases, we are testing more than 20 image quality parameters. We are testing more than 150 camera modules. And by doing this for every individual development phase, we are capturing thousands and thousands of images that have to be analyzed. The work in the Zeiss Imaging Lab is not just for qualification of smartphone camera systems, it's also for the development of technologies and features in general. And I want to point out two features that we recently developed for smartphone camera systems. The first I want to point out is the Zeiss Portrait Style. The Zeiss Portrait Style simulates the bokeh of the lens. A lens always has a background blur and a foreground blur, and the shape of this blur is individual for every lens, like a fingerprint. And in the past there were some iconic lenses like the Zeiss Biotar lens that produce a bokeh that is very unique and very typical, and many ambitious photographers and consumers want to have this typical look of classic lenses on their smartphone. Due to physical and optical limitations, it's not possible in a smartphone camera system to build a lens that produces these kind of bokehs. And therefore we have to replicate the look of these lenses by software. This is achieved by combining depth information together with the information of the optical design of this classical lens that we want to replicate. The depth information is calculated by the camera system of the smartphones, where we analyze the information of the different camera modules. Like the disparity of the eyes, you get 3D information with using two camera systems. And as Zeiss, we have access to the optical designs of these classical iconic lenses, and we can combine it. And there are several ways of doing these combinations, and here you see just some examples from where you can see the actual captured image, which does not show the bokeh. Some simulation tools like the PSF, it's called point spread function, or the ray tracing, which is a brute force method where you just calculate as many as possible image rays and then simulate it. And the last one you see here now is the simulation algorithm that we are using to replicate the Zeiss Biotar lens in a Vivo smartphone. The second feature that we also developed, I want to point out, is color correction. Zeiss has a huge expertise in color and color correction due to its product portfolio. We have medical devices where it's crucial to have the right colors, and also microscopes. And in our division, we have the cinematography lenses where we have color matched lenses, where every lens has to produce exactly the same color like the other ones. And the challenge is to merge the color perception of the brain with the color rendition of a smartphone camera system. This is a very challenging process because it's not just transferring values and numbers that we can measure, it's always also transferring memory colors where the brain says it has to be this color, like green grass or maybe the red sports car, where your brain is saying it must be that color, even if it's not necessarily measurable exactly this color. This topic of color correction is very complex and interesting, and I would love to recommend to you to watch our other expert talk with David, who is our expert for color rendition. So what can we conclude for today's expert talk? We had a short time travel through lens development, from classical lenses to modern smartphone camera systems. You gained insights into development and qualification of an innovative camera system. I took you to my workplace, the Zeiss Imaging Lab. I hope I could give you some insights that were new for you. And I hope this helped you to better understand our enthusiasm with modern imaging technology. Thanks for watching. Stay tuned for new developments.